Hi guys, and welcome back to Aisha.Academy. And in today's video we're going to be going through vectors. So first off, vectors are basically numbers with both size and direction. So this is usually how vectors are represented as. So for instance, if we look at the length of the arrow, that's the magnitude, that's the size. So magnitude is the word that we tend to use for size of vectors. And direction is observed by the direction of the arrowhead. So for instance, if we're going from B to C, or if it's called BC, then it's from B to C. And this is another way of writing vectors. So you may see it in this bracket formation where the X value is on the top and the Y value is on the bottom. So this is the vector that we use for translations or on a grid. So translations, I do have a video in the link below. They're a type of transformation to refresh your memory on those. So here we are drawing our grid. So first of all, when it comes to vectors, if you multiply them by scalar, aka a number, they are going to change in size, but not in direction. So magnitude will change, but direction will stay the same. So for instance, if we've got this vector labeled as b, and we were to multiply it by 2, it would become like this. So notice how the magnitude's gotten bigger, but the direction's still the same. But if you have a negative scalar change, then it's going to change the magnitude and the direction. So here we still have the b, but if it's multiplied by -2, notice how the direction and the magnitude has both changed. So when it comes to adding and subtracting vectors, so for instance, if we have this vector called a, and you are trying to work out, and you also have this vector called b, that arrow down there, the green one, is going to be a plus b because it goes from a and then to b. But then, for instance, let's say if we have this vector b minus b to be exact, and then we have our vector that's still a, if we were had to work out the overall direction, it's going to be a minus b. So basically, that's an example of adding and subtracting vectors. So here's some practice questions to understand this better. So example 1. So in this example, we have vectors and it basically wants us to find the vector AB in terms of A and B. So having a look at the triangle, to go from A to B, we would first of all have to go from A to 0, which is going to be minus A, and then from O to A is going to be B. So the overall vector to get from A to B is going to be minus A plus B, which you can write the other way around if you want. It'll still be the right answer. So now to work out the vector 0 to P in terms of A and B, the easiest way would be to go from 0 to A, which is going to be a positive A, and then from A to P, because the ratio is a 3-to-1 ratio, so A to P is 3-to-1, so it's going to be 3/4 of that length of A to B. So to now work out that size, well, we know that from A to B the vector is B minus A. So if we're going from A to P, it's going to be 3/4 of that. So that's why you have to multiply 3/4 by the vector A to B. And by doing that, you should be left with 3/4 B minus 3/4 A. So again, to go from O to P, you can do it the other way around if it makes life easier for you. Okay, so now that we've worked that out, we now need to add that to O to A, which is A. So to simplify this, it's going to be 1/4 A plus 3/4 B. Example 2. So here we have our vector, and in this scenario, it wants us to work out the actual scalar value of k. So the first thing we're going to do is work out the vector from A to B. So from A to B, we'd go from A to O, which would be -2 because it's a change in direction. And then it would be plus the 2b. So then our vector A to B is going to be 2b minus 2a. Now we need to work out the vector O to P. So we know that from O to P we can go from O to B and then B to P. So that's going to be 2a because it's still the same direction as originally on the triangle. And then again from B to P, so we know that the ratio from BP and AP is 5:3 ratio. So it's going to be 3/8 multiplied by the vector from A to B, which is going to be 2a minus 2b. Because this time it's B to A. So we're going to multiply that out, which would leave you with 3/8 of 2a minus 2b times 3/8, which is going to be 6/8, which will simplify to 3/4. So you're going to end up with your 3/4 A minus your 3/4 B. Okay, so that is our vector OP. And then remember, you have to add the 2b from the O to B. So now we need to simplify all of this. So simplifying this out would leave you the 3/4 A is not going to change, but the minus 3/4 B plus 2b should leave you with an answer of 5/4b. Okay, so we're going to multiply both of them by 4, and that's going to leave us with 4. And then we're also going to factorize them. So it's going to be 4 bracket 3a plus 5b. And then k, which was our scalar quantity, is going to be 4 because that's the number outside the brackets. I hope this makes sense, and please rewatch it if it doesn't make sense. But stay tuned for more content, and thanks for watching.